Okay, dear finite math students, welcome to another video, a lecture video. This one is dedicated to problem 142 in your chapter 3 homework assignment. This is the only problem that we're going to do for this particular video because it's a rather long problem with many different parts, okay? So once again, we're working on problem 142 in your current homework assignment, which is the finance homework for chapter 3. And this is the only problem we're doing for this video because it's a very long problem that contains multiple parts. And it's going to take a while to do this. As usual, I'm using Mathematica to do this. You can use your calculator, you can use Excel, whatever you're going to use. However, I've already explained to you many times in the class that what I use is Mathematica, and you really should be using it too if you want to follow along with my videos. Okay, so let's look at the problem. A person purchased a $145,426 home 10 years ago by paying 15% down and signing a 30-year mortgage at 10.5% compounded monthly. Interest rates have dropped and the owner wants to refinance the unpaid balance by signing a new 20-year mortgage at 6.3% compounded monthly. How much interest will refinancing save? So let's make sure we understand the problem. So there's a house that I, want to buy, and it's $145,426. A house or a condominium, or I suppose it could, it could even be a boat. Whatever it is, it costs $145,426. And I put 15% down, which means I borrowed 85% at 10.5% interest compounded monthly. So that was 10 years ago, but since then, interest rates have dropped, and now I'm eligible for the new interest rate of 6.3% compounded monthly. But that means basically taking out a new mortgage to pay off the old mortgage. All right, so this problem gets a little bit tricky, but that's okay. We're going to do this in steps, and let's see if we can figure it out. And Pearson will tell me if the answers are right or if the answers are wrong. So let's get started here. First of all, let me define the amount. The amount is $145,426 times 85%. And this is the amount of money that's actually being borrowed. And the reason is because I put 15%, down, or actually that's really bad English. I should say my down payment was 15% of the total value of the property. That's better English. Okay, my down payment was 15% of the total value of the property. So I borrowed 85% of $145,426. Okay, so shift enter. Okay, so I'm actually borrowing $123,612.10. Now remember, okay, so let me see something very quickly. Oh, I see. They really cut to the chase. They only want the one answer. So this problem really does have multiple steps. Okay. I thought they would ask for each step. They don't. They just want the final answer. So this is actually a little complicated. So let's do this. Let me move this box over here so we can see the problem a little bit better. And this is a 30-year mortgage. Okay, so we're going to define our initial function. Oh, there's a piece of hair on my computer. we're going to define our initial function. I'm going to call it balance1. Okay. Balance1 is a function of the month. And, oh, I forgot. I need my interest. Interest1 is going to be 1 plus 10.5 divided by 1200. That's 1.00875. Okay, so that's my monthly interest rate. And that's going to be interest 1 times the previous month's balance, and that's going to be minus my payments. What should I call it? Payment, well, I'll just call it payment, or payment 1. I'll call it payment 1, that might be better. Balance 1 of 0 is equal to the amount. Okay. And let me see here. Okay, so what is the actual payment going to be? Balance 1 of 360 months, which is 30 years. So remember, 30 years times 300. Okay, so 30 years times 12 months a year, it's 360 months. Okay, so balance 1, 360. I have to expand this because otherwise it's going to be very difficult to read the output. Okay, so this is a simple linear equation. It's linear in payment 1, and this is going to be equal to 0 because when we're done paying off the mortgage, we owe $0. We owe $0 when we are done paying our debt. We owe nothing or $0. Okay? Ignore the phone in the background. Sorry about that. So, how do we figure out what is payment 1? Set this equal to 0, and what is payment 1? We're figuring out what is payment 1. Okay. So payment 1 is $1,130.73. And I'm going to save that in a variable. I'm actually going to store that in payment 1. Payment 1 is equal to how payment 1 is defined on the previous line. Now the previous line, I believe, is output 6. And if I'm not sure of the output, I could just use the percent symbol, and that refers to the previous output. So for example, if I just type the percent symbol by itself and then shift enter, I get the previous output. So I want payment 1 to actually be saved in a variable, and I'm going to call it payment 1, as it's defined in the previous output. So this is payment 1. That's going to be payment 1. So now what I want to do, see, whenever you make a payment, part of your payment goes to the principal and part of it goes to the interest. And we need to know both. So what we're going to do is I'm going to create a portion to principal list. A portion to principal list. And this is going to be, let me see, balance 1 month minus balance 1 month minus 1, where the month goes from 0 to 360. And let's see what we got. Okay, why am I getting a recursion limit? Oh, I see. Okay, because, okay, so Mathematica is giving me a hard time here. Hold on. And I know why that's happening. Expand expand, expand, expand. And let me see if this makes a difference. Shift Enter. Okay, I'm still getting that. That's very strange. Oh, I see what's happening. The reason, let me erase this output. The reason is because I'm starting at 0. And over here, 0 minus 1 is -1, but there is no balance 1 of -1. So this actually has to go from 1 to 360. Sorry, not 0 to 360, but 1 to 360. Because if I start with 0, 0 minus 1 is -1, and the balance function is not defined when the argument or the month is -1. There is no such thing as a negative first month. So let me see if this helps. Yeah, that makes a big difference. However, I have negative numbers here. I have negative numbers, which I don't want. So actually, this should be reversed. Month minus 1, and then month. Okay, so that looks a little, then we'll get rid of the negative numbers. So let's try that one more time. Shift Enter. Okay, that looks very nice. So that's going to be the portion to principal. So for the first month, I make a payment of $1,130.73 approximately. Only about $49 actually goes to principal. The rest of it goes to paying interest. So the interest is initially very large. And you can see here that the principal actually becomes greater and greater as time goes by. Okay, the principal actually becomes bigger and bigger, which means the interest is going to become correspondingly less. So to figure out the portion to interest, that's really easy. We simply take the payment of $1,130.73 and subtract from that payment each portion to principal. So that's going to be easy to do. And we can do that using Mathematica's list operations. For example, 10 minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see 10 minus 1 is 9, and 10 minus 2 is 8, and 10 minus 3 is 7, and 10 minus 4 is 6. So every number in the list gets subtracted from 10, and then you have a new list. Okay, so that's very easy. Okay, here, let me move up just a little so you can see what I'm doing. Okay, so this is the portion to principal. So then the portion to interest, is simply going to be payment 1 minus the portion to principal. Okay, so initially we see, the portion to interest is initially very large. It's about $1,081 and let's say 60 cents. And then as time goes by, you can see that the portion to interest becomes less and less and less. Okay. So now what we have to figure out is, what is my unpaid balance after 10 years? Okay, so I'm going to have a new amount. I'm going to call this the new amount. And that's going to be balance 1 of 120 months, which is the same as 10 years. 10 times 12 is 120. Okay, so now I am going to take out a new mortgage to pay off the old mortgage. And how much do I have to pay off? I have to pay off $113,256.33. So I'm going to have a new function called balance to month. Oh, I forgot about my interest rate. Hold on. My interest rate is 6.3%. Hold on. So this is going to be, hold on a second. So interest 2 is equal to 1 plus 6.3 divided by 1,200. Okay, so balance to here, hold on. So the new interest rate minus payment to, and initially I owe new amount. There we go. Now let me see here. This is a 20-year mortgage. So 20 times 12 should be 240. Okay. So my new, here, let me just store this in an equation. I'm going to call it equation. Okay. Expand balance to 240 is equal to 0. And then I'm going to solve the equation. What is payment to? Payment to is $831 and about 13 cents every month. Let me store that in a variable. Payment to is equal to payment to as it's defined on the previous line. Payment to is equal to payment to as it's defined on the previous line. Shift enter. So now we have to figure out the total interest. We have to figure out the total interest. Now, figuring out the total interest is actually going to be very easy. So the total interest for this particular loan, what should I call it? Total interest 2 is simply going to be for 240 months, every month for 240 months, you are writing a check for about $831.13. Payment to minus how much money did you initially borrow? You borrowed balance to of 0 is equal to $113,256.33. So that is what we initially borrowed. Okay, so the total interest then for that particular loan or mortgage is $86,214. Now, how much money do we actually save through refinancing? So to figure that out, we have to go back to our original problem. Let me see here, one second. Where is our original problem? Portion to interest. Now remember, portion to interest is divided, it's divided into two parts. We have the first 10 years and the last 20 years. We're interested in looking at the last 20 years. So to look at the last 20 years, this is what we can do. We look at the length. What is the length of my list? Portion to interest. That's 360, right? So if I do portion to interest from the first month all the way to the 120th month, remember, we're not starting at 0 because initially for the 0th month, there's not going to be any interest, okay? So this is going to be the total interest for the first 10 years. Oh, well, let me add up these numbers. Sorry about that. Let me add up these numbers. So that's the total interest for the first 10 years. So the total interest for the last 20 years is going to be portion to interest 121 to 360. And that's going to be $158,118 and about 50 cents. So what I have to do is I have to subtract these two numbers. It's going to be this number here minus this number here. And that's going to give me the answer that Pearson wants, okay? So let me see here. And I think they just want, they just want the final answer. They don't want the intermediate answers. So let's do it like this. I'll just copy and paste. So I'm going to copy this number, paste it, copy this number, paste it. What's the difference between the two numbers? The difference is $71,904 and let's say 49 cents. It says round to the nearest cent is needed. Okay. So, of course, we could use number form to get the same answer. We could do number form answer infinity to two decimal places. I want two digits to the right of the decimal place. All right, so that's going to be $71,904.49. So by refinancing, I actually save $71,904.49 on interest. So let's see if that's correct. Okay, that is correct. That's the answer that Pearson wants. Okay? And that's it. That was a pretty complicated problem. It has many, many steps to it, but it's not that dreadful if you just break it down into the constituent steps. Okay? All right, guys, I think that's going to be enough for today. That was a very complicated problem, and if you have questions about it, email me, and maybe I can help you out. Okay? Thank you. Have a great day. Bye-bye.